Good morning, my name is Mariano Gonzalez. I work for the Office of Student Success. I'm a tutor, math tutor for developmental math. I'm going to cover a couple of things here. Graphing linear inequalities, which is a problem that comes up in class quite a bit. Of how do we graph these things? Let me start off with showing you what this means. This slide here, you see a linear equation on the left-hand side. And what that means is it's got an equal sign there. And also right below that you see the line, a solid line. On the right side you see a linear inequality. Again, it's a solid line only because the inequality, if you can see what the sign is there, it's less than or equal to. Now both of these are fairly easy to graph. Unfortunately, there's a point here that if you see the one on the right, it's kind of shaded on the bottom. And how we do in class, we use what they call a test point method. My next slide here shows on the left side 3 different test points. These are, of course, correspond to the x-axis and the y-axis values. We'd use these values, put them into the equation, and solve for the equation. And if you can see on the right-hand side here, what we have is we have 3 different equations that are all valid solutions. The little blue marks there showing you that these points actually do work. So if they do work, then that makes it easy for us. Now the test point here is that I'm showing here does not work. So which means that the actual solution down at the very bottom of the right hand side is invalid. So that solution does not work. What that means is, as the next slide, as you can see on the right hand side, the test points that we just went through as in equations, all 3 of the ones on the bottom right are valid solutions to the inequality on the right hand side. The one on the top left is an invalid solution, and I put it in red, of course, which means that, hey, this is not one for, so that means that we will shade on the bottom of the line. That's called the test point method. There's another way to do this, and that's a little bit further down the line in the math class. Okay? But let me show you another slide here. There's 2 different types of inequalities. There's one called a non-inclusive boundary, which means that it's the symbol we use only less than or greater than. The one on the right says inclusive, which means that the line is also included in the graph, or all solutions to the inequality are on the line and below the line. So we go back to the graph we're using. Now we're going to do what we call the logic method. Here in this point here, if you look at the left side, we say if the line is greater than or equal to, you shade above the line. So that gives it kind of like basically a point where we look at the graph and say, where are the rest of the valid solutions? Well, if it's above or greater than the actual line itself, then of course it'll be above the line. On the right hand side, now we have the next question we ask ourselves. If the line is less than or equal to, then the shaded part will be, of course, to the bottom of that line. And that's a method that's not necessarily taught all the time. It's kind of a shortcut math solution to the linear inequalities, but it's a very useful one when we have to go through a lot of these graphs. Now to prove that, we go back to our original graphs and we plug in a couple of test points again, but this time we're going to just choose the origin, which is actually 0, 0. We go back to the graphs and you can see on the left hand side, if it's greater than above, that 0, 0 point is not a valid solution, so we do not graph. Okay. On the bottom, we graph above the axis or the actual y-axis line. On the right-hand side, the 0, 0 point we just used in the equation is a valid position or a valid solution, so we graph below the line. And that concludes my presentation, and hopefully this has helped you to understand how to graph inequalities. Have a nice day.